Hello class, Ma'am says here, signing on. In this lecture, you'll learn to iterate over a sequence of elements using the different variations of looping. And you'll be able to build programs that control the flow of code with looping structures. Let's begin. In addition to branching code execution, often it's necessary to repeat code execution until a certain condition is met. This process is called iteration in programming terminology. Suppose you need to prompt a user for input and you continue prompting them until they enter a value that's within an acceptable range of values, or suppose you need to read each line of a data file until you reach the end of the file. In these situations, you'll use the while statement, which creates a looping structure in your code. With a while statement, the code execution iterates until a condition is met, at which point the path of execution continues through the remainder of your program. Let's use the while statement to build a small game that will keep looping over a code block with the game logic required to generate and evaluate a random value. Also important is the code block beneath the while statement. This code block belongs to the while statements and will continue to be repeatedly executed until the Boolean expression evaluates to false. Look at your screen. In this case, we use the random modules randint. It's actually a function that is to generate a random number between 1 to 5. And then we use the role variable. This one will hold the current value of the randomly generated number. And we use count. We use count variable to keep track of how many times we've called the randint function. Okay. Each time we run the code block, the value of role is set to a new random number between 1 and 5. After the last line of the code block runs, the Python interpreter checks the Boolean expression again. If the new value of role is still 5, the process is repeated in a loop until the Boolean expression evaluates to false. In other words, once role equals 5, the Boolean expression is false. The execution path exits the loop and continues with the rest of the program. Again, each time around the code block, we incremented the value of count by 1 here. So we know how many times our code performed the loop. When you run the code, you should see similar output like this one on the screen. All this was run 1, 2, 3 times. Okay. Take note also that the while statement has 3 parts. We have the while keyword, just like what we have here in our example. We have the Boolean expression here in our example, and then we have an end of statement colon symbol. this one. Okay. In certain situations, you might want to break out the while statement prematurely. For example, we might prompt the user for input. If they enter a certain character or term, you might want to exit the loop that circumvents the normal flow. Now we will update the code from the previous step to match the following code listing. In this version of our minigame, we prompt the user for a name. Each time a new name is entered, a random value is generated. That is because of our variable role. The first person to roll a 5 is the one who will win. Okay? The first person to roll a 5 wins. If the player continues to enter a names until 5 is rolled, the Boolean expression is no longer true. Then, the code execution path skips to the else statement to print the winning message. So, our else statement, and this is our winning message. When you run the code and keep entering names, you should eventually see similar output just like this one. We use an if statement to check the value user typed in. If they entered Q, we call the break statement. This is our if statement and this is our break. The break statement instructs the Python interpreter to exit the loop and continue running the code after the while statement's code block. In this case, the else statement is skipped, then there's no winner. When you run the code but enter a Q at some point, you see a similar output like this one. In our output screen here, this sample program was run 3 times. Take note also that both break and else are optional statements in the while looping structure. Okay? Now let's update the code example to handle the case where the user enters nothing by using the continue statement. Let's expand our previous example. Let's make sure that the player doesn't enter an empty string. In other words, if the user selects enter without entering any other keystrokes or merely selects the spacebar, we want to ignore that entry and prompt the user again to enter name. In this case, we perform a gated check on the value entered by the user after we strip out the empty spaces by using the string helper method strip. The name variable is empty. Here, look at your screen. The name, so our name variable here is empty. Then we use a continue keyword to skip the remainder of the code block and go back to the top where we evaluate the Boolean expression and continue looping through the code block. Use our continue keyword here on the screen. By using a gated check, we can avoid the possibility that our program creates roles when there's no name. When you run the code and select the enter key a few times without entering a name, you should see similar output like this one on the screen. So the user input or press the spacebar a few times and then this would happen. That's it. Now we've used the basic assignment operator, a single equal sign signal equal. since we assign a value to our first variable. There are other assignment operators that you should also be aware of. Incrementing a value in a looping structure is a common operation. In this example program, we'll learn how to use other assignment operators that will perform a mathematical operation and assign a new value to a variable in a shortened form. Beyond basic incrementing, there are several potentially useful assignment operators you can employ in your programs. Let's focus on the first line of code in the code block. Count. Here, look at your screen. Count plus equal 1. The plus equal operator takes the current value of count, then adds 1, and then assigns the new value back into count. It's the equivalent of the code count equals count plus 1. And here's our possible output when we run this program. Now let's try comment out the previous code and add code to increment count by 3. You can increment by any value. Let's increment count by 3 until count is no longer less than or equal to 20. And this is the code to increment it by 3. Comment out the code from the previous step and add the following code listing. All this one. So when you run the code, you should see the following sample output here. Alright. Now let's talk about the else statement in looping. With the else statement, you can run a block of code once when the condition no longer is true. Example, print a message once the condition is false, just like what we have here on our screen. Loops are used in programming to repeat a specific block of code, and what we are trying to learn now is to create a while loop in Python, right? So look at your screen. This is our looping statement. Once it is I is no longer less than 6, then this text will be displayed on our screen. When we run this program, you should see similar output like this one. Now, what is while loop in Python? The while loop in Python is used to iterate over a block of code as long as the test expression is true. Test expression or condition is true. We generally use this loop when we don't know the number of times to iterate beforehand. Take note of the syntax of while loop in Python. Here. In the while loop, test expression is checked first. This is our test expression, this is our while keyword. The body of the loop is entered only if the test expression evaluates to true. This could be the line for our body of loop, the while loop. After one iteration, the test expression is checked again. This process continues until the test expression evaluates the false. In Python, the body of the while loop is determining true indentation. Remember? The body starts with indentation and the first indented line marks end. Python interprets any non-zero value as true, none and zero are interpreted as false, as as mentioned in the previous lectures that we had. Now let's talk about the for loop. What is for loop in Python? The for loop in Python is used to iterate over a sequence or other iterable objects. Iterating over a sequence is called traversal. Again, traversal. Take note of our syntax for loop. Here, this is our for keyword. Here, val is the variable that takes the value of the item inside the sequence on each iteration. Loop continues until we reach the last item in the sequence. And the body of for loop is separated from the rest of the code using indentation. This is our body and this is our indentation. Alright? Remember that in the previous example, we comment out the previous code and add code that decrements count by 3. Let's get this one. You can use the minus equal assignment operator, just like here, to subtract a value and then assign it to the variable. What if we want to count backwards from a number until we reach 0? So comment out the code from the previous step that we had earlier and add the following code listing. When you run the code, you should see the following output, just like this one. Now, there are several additional assignment operators, just like what you see here, but their functionality might be less useful in real-world programs. Here is a table of some of the other assignment operators that are available in Python. So again, let's recap. New assignment operators, plus equal and minus equal can simplify your increment and decrement operations. There are many additional assignment operators in Python, but they might not be as useful. Recap with Python loops again. Python has two primitive loop commands, the while and the for loops. The while loop, with the while loop we can execute a set of statements as long as a condition is true. Example here on our screen, print I as long as I is less than 6. Note that, remember to increment I or else the loop will continue forever. There's forever in loop. The while loop requires relevant variables to be ready. In this example, we need to define an indexing variable, our indexing variable I, which we set to 1 here, and then with the break statement we can stop the loop even if the while condition is true. And in our example, this one will exit the loop when I is 3 because of this. Now, when we run this sample program, you could have similar output like this one. Now, in using the continue keyword, just like our example here, the continue keyword help us continue to the next iteration if I is 3 based on this. And when we run this sample program, should see similar output like this one. Note that number 3 is missing in the result. So that's the connection of while, break, and continue. And now the challenge for this lecture, you are tasked to write the code to implement a number of guessing game. So using the techniques that you learned, you generate a random number between 1 and 5 and allow the user to guess. Keep prompting the user for their guess until they guess correctly. Then display the number of guesses. No matter how you do it, your code should produce similar results to the following output given the randomly generated answer and guesses. So just like this one. If the user doesn't enter a numeric value, like a name, there's no need to notify the user of their error. Just keep counting each entry as a guess. So in the following example output, the user enters strings that can't be converted to numbers, but the program keeps running and keeps tallying the number of guesses. Whether you get stuck and need to pick at the solution or you finish successfully, continue on to view a solution to this challenge. You can do it. Now, this one is, the following code is one possible solution for the challenge. Again, this code is only one possible solution. You can come up with your own version and that would be great. If your solution produces the same result as the challenge by using the while statement, you're successful. Take note that a couple of users have reported that the else should be intended so that it pairs correctly with the if statement. It's like here, while then else. In this code example, we actually want else to pair with the while statement. We only want this code to execute once the user guesses the value correctly. So this is one possible solution, and when we run this program, you should see similar output like all this. In this example, we run the program 1, 2, 3, 4 times. Okay? Another challenge is to write the code to implement an improved number guessing game. Rebuild the number guessing game, but this time display the current guess number. If the guess is too low, tell the user your guess is too low, try again. Just like what we have here in the output. If the guess is too high, tell the user your guess is too high, try again. Just like here. If the user enters a non-numeric value, tell the user numbers only please. Like this one. If the so that's it. Also, take note of the output. Here's our sample output here. The prompts and messages have changed when compared to the original challenge. No matter how you do it, again, your code should produce the following output, given the randomly generated answer and the guesses. If the user types in a value that isn't numeric, display an error message. In the following example output, the user enters a few strings and is reminded to only enter the number. Just like what we have here. Got it? The following code is one possible solution for the challenge. Again, this code is only one possible solution. As a Pythonista, you should come up with your own version, your own variables, and make your program as user-friendly as possible. This code, again, is only one possible solution. You should have used the while statement to loop through the game logic, and use the continue statement to handle the case where the user doesn't enter a numeric value. Also, you should have kept track and display the current guess. You should have provided helpful hints like too high and too low when the user guessed incorrectly. When we run the sample program, you could have similar output just like this one. If you were successful, then congratulations. And that ends our discussion. Thanks to Microsoft Educator Community, W3 Schools and Programs for the input. This is Ma'am Says saying the limits of the possible can only be defined by going beyond them into the impossible. Thanks, Arthur, for this one. And so that's it. Watch out for more video lectures. God bless everyone. Thank you for watching. This is Ma'am Says, signing off.